Welcome to my YouTube channel Abrar Electrical World. Now we are starting series on protection of the transmission line. I have made various videos, lectures on differential protection and tried to cover all the aspects related to the differential protection of a transformer especially. We will discuss the differential protection or the busbar protection in a separate series. So this is about the protection of the transmission line. Now when we talk about the protection, it is always about the clearance of the fault as quickly as possible, and also the basic characteristics, that is the reliability, speed, direction, etc., security, reliability must also be ensured. So overcurrent and earth fault relays are the basic relays which can serve our purpose, and they are always there. So when we talk about the protection of the line, it does not mean that it does not include the overcurrent protection and the earth fault protection. It includes these two basic relays always, whether it is a transformer, it is a bus bar, it is a line, whatever. It is 11 kV line, it is the 132 kV line or the 500 kV line. These two relays are there. But the problem is that when we talk about the extra high voltage system, which is basically uh, operated in a ring fashion, and different kind of generators and the regions are connected through the transmission lines, then these relays alone cannot cover all kind of faults, and they, especially when the direction is required. Plus another flaw is that these overcurrent relays have just one quantity to sense for the operation, so they do not look into the other quantity, which is, is the voltage. So this line protection, which is known as the distance protection, it looks into the two quantities, voltage and the current both. So when you consider both two quantities, definitely it becomes more reliable, more secure, directional, and it is able to cover the various different kind of faults, including the power swings, the load characteristics, directions, etc. So in this particular series, we are going to cover the distance protection. The other protections are associated also with the line. Differential protection, you always hear that it is related to the busbar and the transformer. That is not true. Differential protection is also applied on the transmission lines, especially the short lines and the cables. And the pilot of wire protection is also one of the type of the differential protection. When you have the small piece of cable, say 1 kilometer or less or 500 meters, like a line connected to the grid station, substation through a high voltage cable, then the pilot wire protection and the differential protection can be provided on that part of the transmission line. And then the teleprotection is under the distance protection schemes. We will cover all these things in separate lectures because it is impossible to cover everything in one. Now, the surge arrestor I have written here because surge and the lightning arrestor is spelling, mind the spelling here. Lightning arrestor is also part of the protection, but I have already made 3-4 video lectures, and I have uploaded on this topic how to select the register, rating of the surge register, the meaning of the different values of the surge register. I have also shared some parts of the specifications from the NTDC and K Electric. So in a very easy terms, I have tried to um, explain the functions and the selection of the surge register. So in this series, we will only concentrate on the distance protection. Now, this series of lecture on the distance protection will cover the following: distance protection principle and type, characteristics of each type, and advantages, disadvantages, then zone of protection. Don't confuse these zones with the zone of protection on the power system. I have repeated in many lectures that zone of protection of the power transformer is different from the zone of protection of the transmission line. Whenever the question is asked in the interview, normally the students get confused and they mix up with the zones of protection with the zones of protection of the distance relay. They are entirely different phenomena and the different theory and the different kind of things are the type of protection. Then we will also discuss the directional and non-directional and power swing here. See, this power swing cannot be covered by overcurrent relays. So these distance relay can look into those and can take care of that as well. And then teleprotection have very kind of speed. Teleprotection fundamental is that whenever you have a fault close to some bus bar on the transmission line, the closest breaker trips immediately, but the far end breaker takes some time. So to cover that and to minimize that, the other breaker at the far end must trip uh, in the minimum time. We use the teleprotection scheme, and there are various type of teleprotection schemes which are known as DT, DTT, PTT, PUT, etc. But we will discuss in a entirely different video lecture the teleprotection. So here I am just giving you an idea so that you know what we are going to do in this series of lecture. Now see what is distance relay. Distance relay is when impedance or reactance or admittance of a transmission line decreases beyond a predetermined or preset value. So this is the basic, you can say the definition of the distance relay or the distance protection. That the relay looks into the voltage and current both and then measure the voltage and current under the fault condition. You know, when there is a fault, the voltage decreases, and then when there is a and the current increases tremendously. So V by A ratio decreases, and this ratio is compared with the preset value of the ratio of the V and I, which is the normal voltage and normal current. And you know that this impedance is because proportional to the length of the line. Therefore, when we are able to set or measure and make the relay operate and isolate the fault looking into the impedance, it means that impedance is proportional to the distance. So it means that we can also locate the fault, and this helps in locating the fault while surveying the transmission line. So this is a very simple way of explaining the distance relay. That why it is called distance, because it works on the impedance, and impedance is proportional to the distance, that is the length of the line. Therefore, this relay is known as the distance relay, because impedance relay is a kind of the distance relay. So normally when we talk about in a generic term, we call it a distance relay. If you call it an impedance relay, then it will become a type of the distance relay, and there are other types of the distance relays as well. So you will be talking about one kind of distance relay. So whenever you are asked what do you use for the protection of the transmission line, you can start with the overcurrent earth fault and mainly the distance relay, not the impedance relay. Remember this. Now these are three types. Already I told you the impedance, reactance, and the admittance. The unit of admittance is mho, and this name is always mho. But I had in the history of in the history series of my lecture, I have told you that the unit of the admittance has been changed to the Siemens, and but still, when it comes to the engineering and the distance relays and other topics, the name has not been changed to Siemens, and still it is known as the Moore relay. So you will call it a Moore relay or the admittance relay. MHO is the actually ohm reading from the right hand side. Now, impedance relay, this is a type of the distance relay, and the characteristic basically I have shown here. We will discuss these in detail in various other lectures. So this is a relay which is normally not used. It is used only to start the to start sensing of the fault. It has no directional sort of characteristic. You can see that if this is the actually the bus bar origin, this is the bus bar actually, and this is the line. So this relay sees the lines on the both side of the bus bar. This is the bus bar vertical, and this is the line. So this relay looks into the both sides of the bus bar and like two transmission lines at a time. So it will operate and it will have no direction. So this is not very common, but this is used as a starting type of element. When we discuss in detail, these things will be clear to you. But for now or for any question or viva, you should know that this is a non-directional relay. It looks both sides of the bus bar, and therefore it is not normally used independently. This is the further elaboration of this relay. I have taken this picture from the old book of the General Electric Canadian GEC. So I have taken this diagram from there. Now reactance relay, reactance means that no change in reactance, only we are considering the X component, that is the inductive reactance of the line. So this characteristic is horizontal, and also this is used in combination with the other relays. So this is the characteristic of the reactance relay. You can pause and study this if you like. Now the last is the admittance relay. You can see the admittance relay is characteristic is that the circle passes through the origin. In the impedance relay, the center of the circle was at the origin, but here the, the circle touches the origin and it is on the upper side of the x-axis mostly and the right hand side of the y-axis. So this is kind of a directional relay, and this is the known as the admittance relay. Why it is known as admittance? Because it works on the inverse of the impedance, and the characteristic of the impedance is a straight line like y is equal to mx plus b, a linear equation, and if you take the inverse of that equation, you will get a equation of the circle. That is the mathematical part. So whenever you have the inverse of a impedance, it will become a I'm talking about the mathematical equation, then it becomes a circle passing through the origin. Circle passing through the origin. It does not mean the center is at the origin. It circle passes through the origin. So this is the basic principle of the admittance relay. The advantage is that it becomes a directional relay. So this is the most common relay which is used in the distance protection of the transmission line. You can explain when you are asked to explain this. Now these will be zone will look like this one. We will discuss this in detail whenever we come to this admittance relay detailed discussion in the video lecture series. So I hope I am able to explain to you the basic fundamental of the transmission line protection. And again to repeat, there are three type: impedance protection relay, or the reactance relay, or the admittance, or the more relay. And don't forget that the other relay, the differential protection, may also be used for small line or the short cables, short lengths of lines, and plus overcurrent and earth fault are also used as a backup for the for the distance relay. And one thing most important, that distance protection is a non-unit protection. It is not a unit protection. It is a non-unit protection. Remember, differential protection is unit protection, and this is a non-unit protection. This is very confusing question because the engineer and the student think that it looks into the line in one direction and it takes care of the faults on the line. Therefore, it should be a unit protection. No, it is not. It is a non-unit protection. It has not a specific line as its own of protection, like a transformer for differential protection, which is a unit protection. So thank you very much. Subscribe our channel. This is totally voluntary for the education of the engineers and the students. And I hope if you like it, please share it. This will help us in promoting the education for all our engineers and the colleagues and juniors.